Hello everyone. So today we are going to see the mutex in C++. So mutex is used for thread safety and synchronization. It allows basically the access to shared resource which has to be protected. So let us see just a small example how to use the mutex. So we include the mutex library, then we create a mutex mtx. Inside the function, you can see we were having a single line which was just logging out some string. So before logging out, we logged the mutex, and after logging out, we unlocked it. So this is the basic functionality of a mutex. That simple. So what is the problem that mutex actually solves? In multi-threaded programs, threads are often sharing data. So it can be an integer data, let us say, a counter. If multiple threads try to access that counter and they try to increment it, so it can cause a race condition. Why? Because when we say counter plus plus, what it actually does is it first reads the value, then modifies it, then writes it. So there are three operations that goes in the background, due to which the race condition can happen, because since there are multiple threads, they can edit the variable simultaneously and these operations can conflict with each other. So that is called a race condition. So mutex ensures that only one thread at a time enters a critical section and does some operation. The other thread will wait until the operation is completed and the thread unlocks it. So this was the basic example where we saw how mutex is locked and unlocked. Let us see in the program what kind of error do we get and how to solve that with the mutex. So let us first write down the boilerplate code, hash include iostream. We would also require thread and mutex. Now let us first create a mutex. So to create a mutex, we just have to write mutex mtx. This will create a mutex. After that, we would require a counter. So we can say a counter which is set to 0 initially. So let us first write down the main function int main. Inside my main function, what I'll do is I'll create two threads. So I'll create thread T1. It will be performing some task. So we'll create a function task. Let us first write down the thread T2. It will also perform the same task. Now, at the end, we are going to join them. T1.join and T2.join. Then we are just going to log out the counter value. Cout counter. Let us create the task function which our threads are going to perform. So we can have a simple void task which is not going to take any arguments. Inside this, we are going to have a for loop int I equals to 0 till I less than, say, 10,000 I plus plus. Now inside this, I'm going to just increment the counter plus plus. Now let us try to run this program. So I'll go to mutex. So we have compiled it. If I'll execute this, you can see we got a result of 20,000. If I'll execute this again, the output is changing. But ideally, the output should not change if two threads are trying to increment it twice. So the answer should be 20,000. But every time we execute this, we get a different answer. So that is what the race condition actually means. So to solve this, what we can do is we can straight away say mutex.lock and mutex.unlock. Now if I'll try to compile this and let me execute this, so you can see every time we execute this, we get the same result. So there is another way of writing the same thing. Instead of using mutex.lock and unlock, we can use the RAII-style, which is by using the lock guard. So I can say lock guard. Inside this, I have to pass the mutex, lock, and a mtf, the mutex that we have just created. Now if I try to compile this, even then the output remains the same. So you can see this is much more readable as well as it is much more safer. So we will look into these lock cards and other wrappers in the further video. But for now, you just have to remember that mutex is something which protects your critical section. So let us move back to the notes again. So we have already seen a standard example of how to use mutex. We have also seen RAII-style. So what is the difference between these two? You can just remember that if you somehow forget to use the unlock, then in some cases it can cause the deadlock as well because you are not releasing the resource. So that resource will always be occupied. So in some cases it can cause you exception or it can go under deadlock as well. So RAI style provides you automatic unlock when the scope ends and it is exception safe. Now let us move on to the types of mutex. So we have different kinds of mutex. The first one is the standard mutex that we just use in our example, which is STD mutex. It is a basic mutex, no recursive locking happens into it. The second one is the recursive mutex. The same thread can be locked multiple times. I could have used the same MTX to lock twice and then do some operation and then unlock it twice. So that property is allowed by the recursive mutex, but it has to be used very carefully. It makes sometimes a code very tedious to understand, but in some cases it is very useful. So this is the syntax of writing a recursive mutex. Then we have a timed mutex, which basically gives you functionality of trying to lock with a timeout. So you just have to pass a timer into it. It will try to lock within this milliseconds. If it was able to successfully lock, then it is okay. Otherwise, it will just move on without locking because the timeout has happened. So it was not able to acquire the lock and then it will move on to the further execution of the code. Then we have the shared mutex. It was introduced after C++17. It is basically for the reader and writer properties. If you have multiple readers and only one writer, then you should try to use the shared mutex. In some cases, it is very helpful. Say if you have multiple threads which are trying to grab some data from a database, but only one thread is there which is actually writing the data. So in that case, you can try to use the shared mutex because multiple threads should be allowed to read the data. The only thing here to handle is when the thread is writing, at that time, no one should be allowed to read. So that property is given by the shared mutex. So till now, we have seen some terms which are the critical section, the code that accesses shared memory or shared resource. Then we have the race condition, which is outcome depends on the thread timing. Why thread timing? Because at OS level, a CPU can give priority to any thread at any point of time. So it can preempt the CPU and then allow the other thread to execute it. So based on that, different threads can stop and start execution at any point of time, due to which we get a race condition. Then we have the thread safety, which is the code behaves correctly under concurrency. Now let us see some interview tricks. Is mutex expensive? Yes, it is very expensive because it involves OS level primitives sometimes. Can mutex be copied? No, it is not copyable. What is the difference between a mutex and a spinlock? The spinlock itself means that the thread will again and again check when it is able to access the resource. At that time, it goes inside. Otherwise, it will continuously keep on checking. So that is something called a spinlock. But in mutex, the thread goes to sleep if they are not able to acquire the lock. Then it comes back again when the mutex is free. They acquire the lock and they move on. So what does an atomic variable do that a mutex can't do? Or what is the difference between them? So mutex implementation rely heavily on atomic operations internally. A lot of times interviewers also ask you whether mutex internally uses atomic variables or not. Yes, they use atomic properties, but they also use OS level properties. Atomic is completely in the user space, whereas mutex goes into the OS space as well. And mutex provides much more than what atomic variable actually provides you. So the point is, if we can use atomic variable, then why do we use mutex? Why does even mutex exist? So the difference is that atomic variables are faster. They do not have kernel calls, but the point is they are hard to use correctly If they are critical complex sections, then the usage of atomic variables can be much harder. Also, they go under busy waiting, so the CPU cycle also go waste. Whereas if we talk about mutex, they are easy to use. They handle blocking effectively, works for complex logics as well. They are slightly slower because they have kernel overhead, but since they are easy to use and they are easy to accommodate in the complex logic, so they are much more preferred than the atomic. Now, we have already seen the difference between the spin lock and the mutex. So here you can see an example where we have a flag and we check this condition again and again until this condition becomes false. When this condition becomes false, at that time we move on from this while loop. Otherwise, we'll keep on checking the condition again and again because there is nothing inside it. This while loop is specifically to make the threads wait until the condition is satisfied. So it uses only atomic variables. You can see this spin lock is purely atomic, but the CPU cycle are getting wasted because you are continuously checking whether the condition is true or not when the condition goes false. But whereas in mutex, you try atomic first, then you sleep if needed. Once the mutex is free, then you wake up and you acquire the lock. So I have also created a small section to compile all the types of mutex that we have seen. So there is a basic mutex, there is a recursive mutex, we have seen a timed mutex, shared mutex. Lockguard is a kind of wrapper which we'll be seeing later on. Lockguard is not actually a mutex. We use mutex inside the lockguard. It is an RAI style, so we'll see that further. Along with lockguard, we have unique lock and scope lock. So these different kinds of mutex that we have seen, these four kinds of mutex, they can be interchangeably used with these wrappers. So the lock guard can use mutex, recursive mutex as well. Based on the requirement, we use the kind of mutex that we want to use. We'll see them with examples in the further video when we make use of lock guard. So I hope you would have understood a lot about mutex and hopefully it would have cleared a lot of your doubts. So do like and subscribe the video. Thank you.